Good morning, everyone. My name is Akshay Bhati, and today I'll be talking about the topic IO-Link, where I'll tell you what exactly is IO-Link and what kind of data can you expect when you use IO-Link as a communication protocol. So what exactly is IO-Link? IO-Link is a point-to-point communication protocol between 2 points, where this is considered as first point or first node, and this is considered as the second one or the second connection point. This communication is bidirectional, which means that the data can be transmitted from the sensor to the master, or it can be sent from the master to the sensor. Now, this is the entire architecture of IO-Link communication system, where at level 1, we have variety of sensors and devices. For instance, motor starters, encoders, RFID, color sensor, presence detection sensor, ultrasonic pressure sensor, and so on. The next component is this one, which is the IO-Link master, which communicates to the controller, where your controller can be PLC, HMI, tablet, or a smartphone. So the IO-Link master can be located inside the control cabinet somewhere over here, or you can use it as a remote IO, as shown in this picture. So IO-Link is a two-step communication process where the first step is communication between sensors and the master, which I'll be demonstrating later on using a web interface. And the second part is having a communication between the master and the PLC, which my colleague Bill Hintz will demonstrate using a TI portal software. So when we talk about communication between master and sensor, there are 4 data types. First is process data. So this data can take anywhere from 0 to 32 bytes, and it's transmitted cyclically, which means that the data is transmitted in regular intervals. The second one is value status, which is basically like a verification check of the process data, whether it's valid or invalid based on the settings we have. The third one is device data, also referred as service data. So this data type is transmitted acyclically, which means that it can only be transmitted upon a request from a master or a PLC. And the last one are just the events, which are warning messages or error messages from the sensor. Now let's get into the demo. So for this demo, I have control IO-Link master, which is 8-port Ethernet IP IO-Link master. And I have a sensor from SICK called as PowerProx. It looks like this. It's a presence detection sensor, which has 2 discrete outputs. But when you use a sensor over IO-Link, you can get up to 8 switching points and an analog value. So now I'm accessing the master through a web interface. So I'll enter the IP address. As soon as I enter, you can see I got the system information. That means my IO-Link master is live. So after this, as a next step, I'll go to attach devices. So as a next step, we have to install a file called IODD, where IODD stands for IO device description file. Every IO-Link sensor in the market has its unique IODD file, which contains 2 types of file in it. One is .xml, which is like a data file, which is where the program is already written and data is mapped, so you don't have to do programming on your own. And the next type is .png, which are basically just the device image or vendor image. So after we install the IODD file, IO-Link master knows what to expect from the sensor and how to interpret that data. So after we have installed this, we'll go to port 4 because that's where my PowerProx sensor is connected. In the meanwhile, let's go into the document. This is a document from SICK for the sensor, which tells us what kind of data can we expect from PowerProx. So the process data from PowerProx is, it takes 4 bytes, where first 2 bytes are reserved for analog value. The third one is for spare and 1 switching point. And the last one is for all the remaining switching points. So this was about the process data. The next one is service data, which is also referred as ISDU, where ISDU stands for Indexed Service Data Unit. So this kind of data is already mapped. You don't have to do programming to interpret the data. You just need to reference the index and you get that parameter. So now let's look at this data on the IO-Link master, how it looks like. So we have 2 options over here. First one is user role menu, which is basically your service data. And the second one is process data. So as I mentioned earlier, service data is transmitted like upon a request. So you can either read or write the data. So let's do a quick iteration by which you'll understand how to send data or receive data and what kind of numbering system does IO-Link master understands. So let's say I want to find out at port 4, what is the sensor part number. So what I'll do is I'll go to the index of the product ID, which is number 19. I'll go over here and put 19, sub index is 0, so I'll leave as is, and then I'll press get. So I get a value which doesn't actually match my value over here. And the reason is that this value is in hexadecimal numbering format. So when we talk to IO-Link master, we have to use hexadecimal. So now as a next step, what we have to do is we have to convert this into a ASCII format, because that's what is saved inside the sensor. So after I convert it, I get the part number. So this is how you get data from the sensor upon a request. Now let's do another iteration where we'll send the data from the master to the sensor. So for that, let's go down to the area where we have all the switching points. So these are all my switching points, and all my switching points are set to 1000. Now let's do an iteration where I'll change my switching point 5 to say 100 millimeters. Right now it's at 80. So what I'll be doing is, again, I'll go to the index, which is 16388. So I'll put 16388 and sub index is 1. So now another thing over here is these are like 80 millimeter is a decimal value. So if we have to set it to 100, again, we have to convert it into hexadecimal. So we'll go over here, decimal, 100 millimeters to hexadecimal, that comes out to be 0064. So we have to type 0064 and we click this, which is set. So it sends the data, command executed. That means data is saved to the sensor. Now let's refresh it and see what is the value at switching point 5, which is here. It takes a little time to refresh. So let's go down. 1000, and here it comes 100. So that's how you write a data or you send a data from the master. Now let's move on to the process data. And before we get on to the process data, remember that all our switching points are set to 1000 millimeters except switching point 5, which is set to 100. So let's go to process data, and process data, these are all our switching points, and they are transmitted in a like binary format, either 0 or 1. So right now what's happening is my sensor, so this is my sensor, and let's refresh it. So I'm pointing it to the wall on my side, and all these values are 1 except 0, except the switching point 5, which is 0. The reason is because the wall is 512 millimeters away, as you can see in the analog value, and all of these are turned to 1 because it triggers the sensor. It's within the switching distance, which is 1000 millimeters. Now I put my hand in front of the sensor, and switching point 5 should now turn to 1 instead of 0, because it should be less than 100 millimeters. Now analog value will update, and as you can see, BDC 5 is 1 and analog value is 56. So that was all about data types when we talk about communication from master to the sensor or vice versa. Now my colleague Bill Hintz will demonstrate the other part, which is from master to the PLC using TIA portal software.
Thank you, Akshay. Let's see if I can share my screen here. Okay, we should be looking at TIA portal.
Yes, we are, Bill.
Okay, excellent. So for those of you not familiar with TIA, totally integrated automation software is really the Siemens configuration package for an entire automation project. For example, I can, if I were to hit add new device here, I can actually add PLCs and HMIs and PCs and servos and VFDs and so forth all to this same project, including all the networking options and switches and so forth that are included in a TIA total automation project. Now, what we're going to be looking at today are a couple of different devices. I've actually got here a IP67 rated IO link master on Profinet, and we have a SICK FootWise sensor that Akshay just mentioned. What I'd like to show first is how do we actually configure that. So we've actually got a PLC already configured in our project, and I'm going to go ahead and add to that this distributed IO node. And what we're using today is it's called an ET200 Eco Profinet. And we see here we've got a bunch of different options for these Eco devices. So there's digital input modules, digital input and output, analog, and so forth. At the bottom here, we see IO link. And the IO link masters have two different flavors, one of which has some standard digital inputs and outputs. If we want to connect up both IO link devices and standard devices, we could do that with this module. What we're using today is the 4-channel IO link module. You'll see here it says not assigned. This is a Profinet IO device and it needs an IO controller. So we're going to actually just grab that green box and put it on our Profinet network. And now you see that it's actually configured as a device for the IO controller. Now, if I double click on my little guy here, we see that we've got several ports. These are all M12 connectors. So this is a enclosure-less device. We might want to use this on a conveyor and so forth, where we don't want to actually have to have an enclosure. We're just going to mount several of these devices along a conveyor or on a large machine over Profinet, and then have at every one of these nodes, I would have 4 IO link module ports. And we see these 2 green ports. This is an internal switch. So essentially we're going to have a connection to the IO controller here. And if we wanted to actually daisy chain several of these devices on a large machine, we just run it into this top port, out the bottom port, into the next device, and so forth. If I double click on my little green device here, you're going to see our default IP address. I'm going to get that off the base number and just give it a new IP address. And now, if I look inside of my module itself, I see that I've actually got these 4 ports. Now, right now, I've only got 1 sensor connected up, so I'm going to turn off the other 3 and just leave port 1 on. And then now if I go down to the port configuration, this actually kind of defines how much data we're going to be transmitting over IO link. I like to just pick the highest one for starters. That gives us the most freedom to select any device we like once we're configuring the IO master. It's, we can actually come back and change this back down if we're not using all of that bandwidth. Now, if I look at the device itself and right click on it, I actually see that there's an option here for Start Device Tool. And this is actually going to take us off into the IO link configuration tool. I'll go ahead and start that. Now what I've got is it's showing me my IO link master. We see we have 1 IO link and then the other 3 have been deactivated. I've actually, it defaults to the last configuration, so I'm going to just remove that one. And then we see over here on the right side, we have all of these different devices that actually come into the package where we can actually configure them as IO link devices. The SICK ones came in as an IODD file that Akshay mentioned. And to get an IODD file, and all manufacturers of IO link devices will supply this called device description file. And so I can just import an IODD file here and it will add it to my catalog. I've already added the SICK one, so I'm not gonna do it again. But you'll see here now we have the SICK photo eyes and some registration sensors. We happen to be using this one today, which is a analog photo eye that actually has internally 8 different set points that we can configure. And I'm gonna go ahead and grab that and drag it over into my IO-Link first port. We'll see here it gives us, this came from the IODD file, it gives us description of the device and so forth. Now if I look up here under addresses, this actually, the IODD file pre-configures for us several of the different tags that are available to us over, in this case, Profinet through our IO-Link master. And so it's going to actually be able to configure all of these different set points and so forth. And that's what these are. We've got 8 set points. It actually shows the status of some outputs and so forth. And also will show us the analog value that's coming from the sensor. Now what I can do here is I can actually create a PLC data type. And I can just rewrite over this old one, just call it test. I want to replace it, sure. So I've created a UDT file, which actually is the description of all these different IO tags. Now, if I were to actually go and jump out of this tool, it's going to ask me, do I want to save these changes into the IO controller? And it's going to go ahead and save that. And now we'll see we've got our actual device here, and we can actually import in those tag names. So I can do an external source file. And if I go over and grab that test UDT that it created, I can actually generate some tag blocks. And now we see we've gotten imported into our TIA all these different bits that were pre-configured through that IODD file. Now, oftentimes the manufacturer is going to come in and give us some names that may not make sense for our project. So we're free to change those. So if I wanted to make these, just give it a set point name or something. And maybe we'll just rename a bunch of these. Now I can go into my PLC and look at my tags. And maybe we'll just add a new tag table just for the sensor. And I'll call that SICK photo eye. So I've got a blank little PLC tag definition here. We'll just call this photo eye 1. And I look at my data types, and now I see that I've got this SICK data type that I can actually configure. And now we've got all of our tag names came in, including our renamed tag names and so forth. At this point, I can go ahead and download that into my PLC. Load her up. Restart the PLC. And now if I look at my numbers in here, I should see the analog value going in and out under the process data analog value at the top there. Now also I've got these set points. Now they're set for pretty close, so I've got to come up pretty close in here. And once we get at, we see that we've now defined all these tag names, came in from our configuration tool. If I wanted to write a real simple program, I can just go in here and we'll just do some little ladder logic. Let's make sure that goes in the right spot. Get rid of that little guy. And now I look under my tags, I see I have my PE1 and all the different tags that are defined for that PE1. I can just grab one of these set points. And my output. And we just download that guy. Let's see what we got. So now as I go in and out, my tag names are all working. I'm firing off an output. You get an idea how easy it is to get a tremendous amount of data. Now remember, with IO-Link, we've only got 3 wires running out to our sensor there, and that's just going to be the plus 24, the return 0 volt, and a signal line. And if we were to have the equivalent in digital photo eyes, we need 8 photo eyes, 8 digital inputs, and an analog input to tell us what the full distance is, and all that associated wiring. IO-Link eliminates a lot of that. So now we can actually just have the 3 wire, and this is actually on an M12 connector. So we don't really do any wiring at all other than just connect it right up. We have an IP67 rating. We run them out along our conveyor system or large machine, and we can have lots of these guys. We may have several of them. Probably doesn't want me to do this when I'm online. So if I were to have several of these devices, I can just go ahead and have 4 IO-Link ports at every one of these devices along a conveyor, and that gives us a tremendous amount of data without actually having to have an enclosure or the associated wiring to go along with it. That, in a nutshell, is IO-Link in TIA.